All right. So let's go ahead and think about our shells. When we rotate about 8 different axes of rotation. So here I'm rotating about the line x equals a. Okay? We're still going to have the concept of 2 pi times radius times height times thickness, except we're going to have to adjust something in our setup. Okay? So I'm going to come over here, and here is the rectangle that we're going to focus on with thickness dx that we're rotating about the line x equals a. I want you to take a moment and talk about in your pod what the radius of these shells would be and what the height of these shells would be. 1, 2, 3, go. It's okay to be wrong. I just want you to think through it. Keep talking.
Because if x is the distance from the axis to whatever rectangle we're at, then a minus x is the distance from the rectangle to the center of rotation.
All right. Pod 4, does our height change? Does the height of our rectangles change at all? Huh? Yeah, you are.
No.
Okay, so we're still going to take top function minus bottom function for our height, right? Who has an idea of what the radius would be instead? Connor?
A minus x.
Connor thinks a minus x. Is he right? I'm getting a couple head nods. So our radius is this distance right here, the distance from our rectangle to the axis of rotation, okay? Well, we know that if we are going from here to here, I'll draw it in green, here to here we called x yesterday, didn't we? Right? So if this distance is a and this distance is x, then yes, a minus x would be that blue radius. This blue radius that we have highlighted right here. Okay. Does anybody need me to go through again why that's a minus x? Okay. So that is the difference. That's the only difference we have when we have a different axis of rotation. So we're going to do a couple examples in terms of x, and then we'll look at how it's, similar for in terms of y. All right. So here's our first example. We want the region bounded by 4 minus x squared, x equals 0, y equals 0, about the line x equals 2. So write down what you need to, and then we'll draw our picture together.
Stop there.
It keeps going forward.
No, don't do that.
No.
Do you know it off the top of your head? She's a math teacher. She might.
All right, 4 minus x squared, what does that look like? Okay, so negative x squared means,
Up, 4, down.
okay, up 4 and then it opens down. Where is it going to intersect the x-axis at? 2. And we're only concerned about the right-hand part of the parabola because we have x equals 0 and y equals 0 that we want to bound it. Okay? So we're going to take this and we're going to rotate it about the line x equals 2. Right? So let's go ahead and draw in a rectangle parallel to the axis of rotation so that we can create shells. So we have 2 pi times radius times height times thickness. Okay? Our limits of integration, Grant, what are they?
It means 0 to 2.
0 to 2 because those are the x values that our region stretches from. Okay. Our radius, we are concerned with the distance from each arbitrary rectangle to the axis of rotation. Cole, what did you say?
I was just adding on to what you said.
2 minus x? Yes, this radius right here is 2 minus x. X would be from y-axis to rectangle. 2 would be from y-axis to 2, and so we have 2 minus that x value. Okay. The height of each of those rectangles. Isaac, x, what would it be? 4 minus x squared. And there's the volume of that rotation. Now, before you start typing into your calculator, if this was a problem that you had to do by hand, what would you need to do? You would have to multiply those two binomials together and then take your antiderivative. Okay? Well, go ahead and use your calculator. Where you at?
40 pi over 3.
40 pi over 3? Do we agree with Logan? Yeah? Okay. Good. All right, so our next example. We're going to create a bundt cake out of this volume of revolution. So we have the parabola enclosed by the x-axis and the parabola. Hold on. I think that's supposed to be an equals. Does that look better? Okay, so we have 3x minus x squared and the x-axis, and we're going to revolve it around the line x equals -1. Write down the information that you need. the parabola 3x minus x squared, okay? It opens down. What else do we know about it? We have zeros of 0 and 3. And the x-axis is enclosing it as well. So that would be our region right there. And we want to rotate it about the line x equals -1. So we're going to use some shells, which means we're going to have a parallel rectangle to the axis of rotation. Rotating around axis. Okay, so we have shells. 2 pi radius times height times thickness. Aaron, what are our limits of integration?
0 to 3.
0 to 3. Our radius. Who wants to take a shot at the radius? Austin.
Isn't it x plus 1 or x minus -1?
Austin is saying x plus 1 or x minus -1.
I agree.
You agree?
I wrote it 1 plus x.
Okay. 1 plus x plus 1, x minus -1. They all mean the same thing, right? Okay. Austin, can you explain why you have x plus 1?
Since it's on the more positive side, the x, and it's to the right, then you would have to have x be the radius plus whatever the distance between the beginning and the...
Okay. So you basically took that this is x away from the y-axis and then minus our line -1. Some of you may view it as, all right, there's the distance of x from here to the y-axis, and there's one more unit to go. All right, so we have x plus 1. All right, so Logan, what is the height of our rectangles then?
3x minus x squared.
Okay, so in your calculators, please find me the volume.
90 pi over 4.
You already have it?
Yeah,
What is it?
90 pi over 4.
No, 45 over 4. I think that is your only multiplier. No, because then it's not one.
What is that?
What was your question?
He just multiplied. He didn't put it in the quantity, so he didn't.
Oh, that is a problem.
No, it's not that answer.
It's not that answer?
That's correct. That's what I got.
Yeah, that's what I got. Never mind, that's the right answer. 90 pi over 4 divided by
Reduce.
X. Yes, so that's.
If you wrote 90 pi over 4, am I going to count it wrong?
No, but you put a note saying reduce.
The AP test does not count off if you don't reduce, so I'm not going to count off if you don't reduce.
What if we put like a weird decimal, then we put pi by it? Like 11.25.
Don't. Oh, that drives me nuts. All right. Let's do one in terms of y.
Just one on our own.
Let's not.
455 or 5.
Don't be a dumb.
It's just keep multiplying if I say it. 900 over 40.
If you want to be obnoxious, I can be obnoxious right back. I'm not sure if that's a battle you want to start.
Game on.
No. Okay, let's really think about what this looks like. I want you to turn to your neighbor and I want you to describe what this parabola looks like.
Just go around one.
Thank you.
opens right.
Yeah, because if you radical, and then you add the Q, it's substitution. Right. I think so.
Okay, what does this parabola look like? It is a parabola.
It's shooting star.
To the right, two, open sideways.
Okay. Shifted right to open sideways. Cole, you're saying shifted up to? Need a tiebreaker here. Which is it? Right to or up to?
Up to. Right to. Oh no, it is right to. If you look at that one.
It's up to.
It is up to. It is up to. Since it's with the y, it moves in the direction with the y.
Good question.
Okay? Kind of like if it was y equals x minus 2 squared, this would be shifted right. X we associate with horizontal, right? Y we associate with vertical. So since it's with the y, it moves vertically. Okay? Okay, Cole, I kind of like what you did. Cole thought about it as, well, if we take the square root, we have x equals plus or minus x equals y minus 2, and so we have our square root plus 2, and so you knew that that square root needed to be shifted up to if you wrote it in terms of y. That would be another way to think about it if you needed it. Okay? All right, and then we have the line y equals x. And we are rotating about the line y equals -1. Okay. This is one where the shell method is going to be way nicer because the function on the right is consistent, the function on the left is consistent. But if we try to draw vertical rectangles, we would have to do more than one integral. We don't really want that, do we? Okay? All right, so our shell method, 2 pi RH thickness. Okay? Our radius is the distance from any given rectangle to the axis of rotation. Jake Ralston, what is our radius? I like it, except please be careful. No, you're getting further away.
X plus 9. 4.
Y plus 1 is our radius. Okay? We have rectangles with thickness dy, so everything needs to be written in terms of y. Okay? The height of each of these shells we can describe as what, Joe Manor?
Y minus 2 squared. Minus x. Or minus 1.
Y.
What do you think?
Oh, right. Okay, so y minus 2 squared.
Like this? Okay, good. We always need to think of top minus bottom, right minus left. So we have right minus left. Okay? Our limits of integration, Alex, do you know what they are? 1 to 4, and how did you get 1 to 4? Okay, so Alex used her graph to figure out that this is y is 1 and this is y equals 4. Okay, you can use algebra, you can use your graph, whatever you need to do. All right, so when you plug this into your calculator, what is our volume?
All of those.
Logan, what's your question?
I just didn't know why it was y minus. Why don't we do the top first? Wait.
Well, since we have horizontal rectangles, we have to do right minus left. So this right function is the line y,
Okay.
and the left function is the parabola y minus 2 squared.
Okay.
Okay, so your radius is either going to be axis of rotation minus x or x minus axis of rotation depending on where it is. Here our axis of rotation was more positive, so it had to be that a minus x. Here our axis of rotation was more negative, so it had to be x minus a. Okay, that's the only difference from yesterday to today. All right, now go ahead and get out your gold sheets because I want to tell you which one I want you to do by hand. Yes, I said which one I want you to do by hand. $23. Nice call. Is the one I want you to do by hand. The rest you can integrate with your calculator. You guys need to be practicing making these graphs without your calculator. Some of you are getting way too reliant on your calculator, and you need to know that Monday's quiz will be half no calculator, half calculator, which means you're going to have to come up with 3 graphs on your own without the aid of your calculator. So please practice graphing these as much as you can without a calculator.